everyone, welcome back to the Comptia Network Plus course, Introduction to Wireless Technology. Transmitting a signal using a typical 802.11 specification works a lot like it does with a basic Ethernet hub. They're both two-way forms of communication and they both use the same frequency to both transmit and receive, often referred to as half duplex as mentioned in the chapter introduction. Wireless LANs, WLANs, use frequencies or use radio frequencies RF that are radiated into the air from the antenna that creates radio waves. These waves can be absorbed, refracted or reflected by walls, water and metal surfaces, resulting in low signal strength. So because of this innate vulnerability to surrounding environmental factors, it's pretty apparent that wireless will never offer us the same robustness as a wired network can. But that still doesn't mean we're not going to run wireless. We can increase the transmitting power and we'd be able to gain a better transmitting distance, but so can create some nasty distortion, so it has to be done carefully. By using higher frequencies we can attain higher data rates, but this is unfortunately at a cost of decreased transmitting distance. And if we use lower frequencies we get to transmit greater distances but at a lower data rates. This should make it pretty clear to you that understanding all the various types of wireless LANs you can implement is imperative to creating a LAN solution that best meets the specific requirements of the unique situation you're dealing with. Also important to note is the fact that the 802.11 specifications were developed so that there would be no licensing required in most countries to ensure that the user has the freedom to install and operate without any licensing or operating fees. This means that any manufacturer can create wireless networking products and sell them at a local computer store or whatever. It also means that all our computers should be able to communicate wirelessly without configuring much, if anything at all. Various agencies have been around for a very long time to help govern the use of wireless devices, frequencies, standards, and how the frequency spectrums are used. Table 12.1 shows the current agencies that help create, maintain, and even enforce wireless standards worldwide. Table 12.1 Wireless Agencies of Standard. Agency Institute of Electrical and Electronic Engineers. Purpose: creates and maintains operational standards. Website: www.ieee.org. Federal Communications Commission (FCC) regulates the use of wireless devices in the US. www.fcc.gov. European Telecommunications Standard Institute, chartered to produce common standards in Europe. www.etsi.org. Wi-Fi Alliance promotes and tests for wireless LAN interoperability. www.wifi-.com. Wireless Lan Association educates and raises consumer awareness regarding wireless LANs. www.wlana.org. Because wireless LANs transmit over radio frequencies, they're regulated by the same types of laws used to govern things like AM, FM radios. In the United States, it's the Federal Communications Commission (FCC) that regulates the use of wireless LAN devices, and the Institute of Electrical and Electronic Engineers (IEEE) takes it from there and creates standards based on what frequency the FCC releases. for public use. The FCC has released 3 unlicensed brands for public use: 900 megahertz, 2.4 gigahertz and 5 gigahertz. The 900 megahertz and 2.4 gigahertz bands are referred to as the industrial, scientific and medical ISM bands, and the 5 gigahertz band is known as the unlicensed National Information Infrastructure UNII band. Figure 12.1 shows where the unlicensed bands sit within the RF spectrum. A newer addition to this, not shown in the figure, is the 60 gigahertz band, which is used for the new 802.11ad standard. That is a very high speed, short range wireless technology. So it follows, if you opt to deploy wireless in a range outside the 3 public bands as shown in figure 12.1, you need to get a specific license from the FCC to do so. Once the FCC opened the 3 frequency ranges for public use, many manufacturers were able to start offering myriad products that flooded the market, with 802.11bgn being the most widely used wireless network found today. Figure 12.2 shows the wireless LAN history that is important to us. Although wireless transmissions date back many years, the type we really care about is the wireless as related to wireless LANs starting in the 1990s. Use of the ISM band started in early 1990 and it's deployed today in multiple environments, including outdoor links, mesh networks, office buildings, healthcare facilities, warehouses and homes. 802.11ac was released in December 2013, and although it isn't shown in figure 12.2, it will be the newest, hottest 802.11 standard for the next few years. I'll discuss 802.11ac in detail throughout this chapter. The Wi-Fi Alliance grants certification for interoperability among 802.11 products offered by various vendors. This certification provides a sort of comfort zone for users purchasing the many types of products, although in my personal experience it's just a whole lot easier if you buy all your access points from the same manufacturer. In the current US WLAN market there are several accepted operational standards and drafts created and maintained by the IEEE. We'll now take a look at these standards and then talk about how the most commonly used standards work. Cellular. As part of implementing the appropriate cellular and mobile wireless technologies and configurations, consider the following options. GSM, Global System Mobile, is a type of cell phone that contains a subscriber identity module SIM chip. These chips contain all the information about the subscriber and must be present in the phone for it to function. One of the dangers with these phones is cell phone cloning, a process where copies of the SIM chip are made, allowing another user to make calls as the original user. Secret key cryptography is used using a common secret key when authentication is performed between the phone and the network. Okay. FDMA, Frequency Division Multi-Access. FDMA is one of the modulation techniques used in cellular wireless networks. It divides the frequency range into bands and assigns a band to each subscriber. This was used in 1G cellular networks. TDMA, Time Division Multi-Access, increases the speed over FDMA by dividing the channels into time slots and assigning slots to calls. This also helps to prevent eavesdropping in calls. CDMA code division multi-access assigns a unique code to each call or transmission and spreads the data across the spectrum, allowing a call to make use of all frequencies. The 802.11 standards. Wireless starts with 802.11. There are various other up-and-coming standard groups as well, like 802.11 AC. Even cellular networks are becoming huge players in our wireless experience. But for now, we're going to concentrate on the 802.11 standards committee and subcommittees. IEEE 802.11 was the first original standardized wireless LAN at 1 megabits per second and 2 megabits per second. It runs in the 2.4 gigahertz radio frequency. It was ratified in 1997, although we didn't see many products pop up until around 1999 when 802.11b was introduced. All the committees listed in Table 12.2 made amendments to the 802.11 standard except for 802.11f and 802.11t, which produced standalone documents. Table 2802.11 committees and subcommittees. Committee and purpose. IEEE 802.11a 54 megabits per second, 5 gigahertz. IEEE 802.11 AC 1 gigabits per second, 5 gigahertz. IEEE 802.11b enhancements to 802.11 to support 5.5 megabits per second and 11 megabits per second. IEEE 802.11.c bridge operations procedures included in the IEEE 802.1d standard. IEEE 802.1d international roaming extensions. IEEE 802.11e quality of service. IEEE 802.11f inter-access point protocol. IEEE 802.11g 54 megabits per second, 2.4 gigahertz backwards compatible with 802.11b. IEEE 802.11h dynamic frequency selection and transmit power TPC at 5 gigahertz. IEEE 802.11i enhanced security. IEEE 802.11j extensions for Japan and US public safety. IEEE 802.11k radio resource measurement enhancements. IEEE 802.11m maintenance of the standards odds and ends. IEEE 802.11n higher throughput improvements using multi-input, multi-output MIMO antennas. IEEE 802.11p wireless access for the vehicular environment wave. IEEE 802.11r fast roaming. IEEE 802.11s ESS extended service set mesh networking. IEEE 802.11t wireless performance prediction. IEEE 802.11u internetworking with non-802 networks. IEEE 802.11v wireless network management. IEEE 802.11w protected management frames. IEEE 802.11y 3650 3700 operation in the US. So I'm going to leave you here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.